Galileo di Vincenzo Bonaiuti de Galilei, Elio L. Leo, Galileo Galilei, EEO, Italian. The 15th of February 1564 to the 8th of January 1642. Commonly referred to as Galileo, was an astronomer, physicist and engineer, sometimes described as a polymath, from Pisa, in modern-day Italy. Galileo has been called the father of observational astronomy, modern physics, the scientific method, and modern science. Galileo studied speed and velocity, gravity and free fall, the principle of relativity, inertia, projectile motion, and also worked in applied science and technology, describing the properties of pendulums and hydrostatic balances. He invented the thermoscope and various military compasses, and used the telescope for scientific observations of celestial objects. His contributions to observational astronomy include telescopic confirmation of the phases of Venus, observation of the 4 largest satellites of Jupiter, observation of Saturn's rings, and analysis of sunspots. Galileo's championing of Copernican heliocentrism, Earth rotating daily and revolving around the Sun, was met with opposition from within the Catholic Church and from some astronomers. The matter was investigated by the Roman Inquisition in 1615, which concluded that heliocentrism was foolish, absurd, and heretical since it contradicted Holy Scripture. Galileo later defended his views in Dialogue Concerning the Two Chief World Systems, 1632, which appeared to attack Pope Urban VIII and thus alienated both the Pope and the Jesuits, who had both supported Galileo up until this point. He was tried by the Inquisition, found vehemently suspect of heresy, and forced to recant. He spent the rest of his life under house arrest. During this time, he wrote 2 New Sciences, 1638, primarily concerning kinematics and the strength of materials, summarizing work he had done around 40 years earlier. Galileo was born in Pisa, then part of the Duchy of Florence, Italy, on the 15th of February 1564, the first of 6 children of Vincenzo Galilei, a lutenist, composer, and music theorist, and Giulia Aminotti, who had married in 1562. Galileo became an accomplished lutenist himself and would have learned early from his father a skepticism for established authority. 3 of Galileo's 5 siblings survived infancy. The youngest, Michelangelo, or Michelagnolo, also became a lutenist and composer who contributed to Galileo's financial burdens for the rest of his life. Michelangelo was unable to contribute his fair share of their father's promised dowries to their brothers-in-law, who would later attempt to seek legal remedies for payments due. Michelangelo would also occasionally have to borrow funds from Galileo to support his musical endeavors and excursions. These financial burdens may have contributed to Galileo's early desire to develop inventions that would bring him additional income. When Galileo Galilei was 8, his family moved to Florence, but he was left under the care of Muzio Tedaldi for 2 years. When Galileo was 10, he left Pisa to join his family in Florence, and there he was under the tutelage of Jacopo Borghini. He was educated, particularly in logic, from 1575 to 1578 in the Vallombrosa Abbey, about 30 kilometers southeast of Florence. Career as a scientist. Although Galileo seriously considered the priesthood as a young man, at his father's urging he instead enrolled in 1580 at the University of Pisa for a medical degree. He was influenced by the lectures of Girolamo Barro and Francesco Buonamici of Florence. In 1581, when he was studying medicine, he noticed a swinging chandelier, which air currents shifted about to swing in larger and smaller arcs. To him, it seemed, by comparison with his heartbeat, that the chandelier took the same amount of time to swing back and forth, no matter how far it was swinging. When he returned home, he set up 2 pendulums of equal length and swung one with a large sweep and the other with a small sweep and found that they kept time together. It was not until the work of Christian Huygens, almost 100 years later, that the tautochrone nature of a swinging pendulum was used to create an accurate timepiece. Up to this point, Galileo had deliberately been kept away from mathematics, since a physician earned a higher income than a mathematician. However, after accidentally attending a lecture on geometry, he talked his reluctant father into letting him study mathematics and natural philosophy instead of medicine. He created a thermoscope, a forerunner of the thermometer, and, in 1586, published a small book on the design of a hydrostatic balance he had invented, which first brought him to the attention of the scholarly world. Galileo also studied disegno, a term encompassing fine art, and, in 1588, obtained the position of instructor in the Accademia delle Arti del Disegno in Florence, teaching perspective and chiaroscuro. Being inspired by the artistic tradition of the city and the works of the Renaissance artists, Galileo acquired an aesthetic mentality. While a young teacher at the Accademia, he began a lifelong friendship with the Florentine painter Segoli. In 1589, he was appointed to the chair of mathematics in Pisa. In 1591, his father died, and he was entrusted with the care of his younger brother Michelagnolo. In 1592, he moved to the University of Padua where he taught geometry, mechanics, and astronomy until 1610. During this period, Galileo made significant discoveries in both pure fundamental science, for example, kinematics of motion and astronomy, as well as practical applied science, for example, strength of materials and pioneering the telescope. His multiple interests included the study of astrology, which at the time was a discipline tied to the studies of mathematics and astronomy. Scientific contribution. Scientific methods. Galileo made original contributions to the science of motion through an innovative combination of experiment and mathematics. More typical of science at the time were the qualitative studies of William Gilbert on magnetism and electricity. Galileo's father, Vincenzo Galilei, a lutenist and music theorist, had performed experiments establishing perhaps the oldest known nonlinear relation in physics. For a stretched string, the pitch varies as the square root of the tension. These observations lay within the framework of the Pythagorean tradition of music, well known to instrument makers, which included the fact that subdividing a string by a whole number produces a harmonious scale. Thus, a limited amount of mathematics had long related music and physical science, and young Galileo could see his own father's observations expand on that tradition. Galileo was one of the first modern thinkers to clearly state that the laws of nature are mathematical. In the Essayer, he wrote philosophy is written in this grand book, the universe. It is written in the language of mathematics, and its characters are triangles, circles, and other geometric figures. His mathematical analyses are a further development of a tradition employed by late scholastic natural philosophers, which Galileo learned when he studied philosophy. His work marked another step towards the eventual separation of science from both philosophy and religion, a major development in human thought. He was often willing to change his views in accordance with observation. In order to perform his experiments, Galileo had to set up standards of length and time, so that measurements made on different days and in different laboratories could be compared in a reproducible fashion. This provided a reliable foundation on which to confirm mathematical laws using inductive reasoning. Galileo showed a modern appreciation for the proper relationship between mathematics, theoretical physics, and experimental physics. He understood the parabola, both in terms of conic sections and in terms of the ordinate, y, varying as the square of the abscissa, x. Galileo further asserted that the parabola was the theoretically ideal trajectory of a uniformly accelerated projectile in the absence of air resistance or other disturbances. He conceded that there are limits to the validity of this theory, noting on theoretical grounds that a projectile trajectory of a size comparable to that of the Earth could not possibly be a parabola, but he nevertheless maintained that for distances up to the range of the artillery of his day, the deviation of a projectile's trajectory from a parabola would be only very slight. Astronomy. Using his refracting telescope, Galileo observed in late 1609 that the surface of the Moon is not smooth. Early the next year, he observed the 4 largest moons of Jupiter. Later in 1610, he observed the phases of Venus, a proof of heliocentrism, as well as Saturn, though he thought the planet's rings were 2 other planets. In 1612, he observed Neptune and noted its motion, but did not identify it as a planet. Galileo made studies of sunspots, the Milky Way, and made various observations about stars, including how to measure their apparent size without a telescope. Engineering. Galileo made a number of contributions to what is now known as engineering, as distinct from pure physics. Between 1595 and 1598, Galileo devised and improved a geometric and military compass suitable for use by gunners and surveyors. This expanded on earlier instruments designed by Niccolò Tartaglia and Guidobaldo del Monte. For gunners, it offered, in addition to a new and safer way of elevating cannons accurately, a way of quickly computing the charge of gunpowder for cannonballs of different sizes and materials. As a geometric instrument, it enabled the construction of any regular polygon, computation of the area of any polygon or circular sector, and a variety of other calculations. Under Galileo's direction, instrument maker Marcantonio Mazzoleni produced more than 100 of these compasses, which Galileo sold, along with an instruction manual he wrote, for 50 lire and offered a course of instruction in the use of the compasses for 120 lire. In 1593, Galileo constructed a thermometer, using the expansion and contraction of air in a bulb to move water in an attached tube. In 1609, Galileo was, along with Englishman Thomas Harriot and others, among the first to use a refracting telescope as an instrument to observe stars, planets or moons. The name telescope was coined for Galileo's instrument by a Greek mathematician, Giovanni Domitiani, at a banquet held in 1611 by Prince Federico Cesi to make Galileo a member of his Accademia dei Lincei. In 1610, he used a telescope at close range to magnify the parts of insects. By 1624, Galileo had used a compound microscope. He gave one of these instruments to Cardinal Zollern in May of that year for presentation to the Duke of Bavaria, and in September, he sent another to Prince Cesi. The Linceians played a role again in naming the microscope a year later when fellow Academy member Giovanni Faber coined the word for Galileo's invention from the Greek words micron, meaning small, and scopon, meaning to look at. The word was meant to be analogous with telescope. Illustrations of insects made using one of Galileo's microscopes and published in 1625 appear to have been the first clear documentation of the use of a compound microscope. In 1612, having determined the orbital periods of Jupiter's satellites, Galileo proposed that with sufficiently accurate knowledge of their orbits, one could use their positions as a universal clock, and this would make possible the determination of longitude. He worked on this problem from time to time during the remainder of his life, but the practical problems were severe. The method was first successfully applied by Giovanni Domenico Cassini in 1681 and was later used extensively for large land surveys. This method, for example, was used to survey France, and later by Zebulon Pike of the Midwestern United States in 1806. For sea navigation, where delicate telescopic observations were more difficult, the longitude problem eventually required the development of a practical portable marine chronometer, such as that of John Harrison. Late in his life, when totally blind, Galileo designed an escapement mechanism for a pendulum clock, called Galileo's escapement, although no clock using this was built until after the first fully operational pendulum clock was made by Christian Huygens in the 1650s. Galileo was invited on several occasions to advise on engineering schemes to alleviate river flooding. In 1630, Mario Guiducci was probably instrumental in ensuring that he was consulted on a scheme by Bartolotti to cut a new channel for the Bisenzio River near Florence. Physics. Galileo's theoretical and experimental work on the motions of bodies, along with the largely independent work of Kepler and René Descartes, was a precursor of the classical mechanics developed by Sir Isaac Newton. Galileo conducted several experiments with pendulums. It is popularly believed, thanks to the biography by Vincenzo Viviani, that these began by watching the swings of the bronze chandelier in the Cathedral of Pisa, using his pulse as a timer. Later experiments are described in his two new sciences. Galileo claimed that a simple pendulum is isochronous, i.e. that its swings always take the same amount of time, independently of the amplitude. In fact, this is only approximately true, as was discovered by Christian Huygens. Galileo also found that the square of the period varies directly with the length of the pendulum. Galileo's son, Vincenzo, sketched a clock based on his father's theories in 1642. The clock was never built and, because of the large swings required by its verge escapement, would have been a poor timekeeper. Galileo is lesser known for, yet still credited with, being one of the first to understand sound frequency. By scraping a chisel at different speeds, he linked the pitch of the sound produced to the spacing of the chisel's skips, a measure of frequency. In 1638, Galileo described an experimental method to measure the speed of light by arranging that two observers, each having lanterns equipped with shutters, observe each other's lanterns at some distance. The first observer opens the shutter of his lamp, and, the second, upon seeing the light, immediately opens the shutter of his own lantern. The time between the first observer's opening his shutter and seeing the light from the second observer's lamp indicates the time it takes light to travel back and forth between the two observers. Galileo reported that when he tried this at a distance of less than a mile, he was unable to determine whether or not the light appeared instantaneously. Sometime between Galileo's death and 1667, the members of the Florentine Accademia del Cimento repeated the experiment over a distance of about a mile and obtained a similarly inconclusive result. The speed of light has since been determined to be far too fast to be measured by such methods. Galileo put forward the basic principle of relativity, that the laws of physics are the same in any system that is moving at a constant speed in a straight line, regardless of its particular speed or direction. Hence, there is no absolute motion or absolute rest. This principle provided the basic framework for Newton's laws of motion and is central to Einstein's special theory of relativity. Mathematics. While Galileo's application of mathematics to experimental physics was innovative, his mathematical methods were the standard ones of the day, including dozens of examples of an inverse proportion square root method passed down from Fibonacci and Archimedes. The analysis and proofs relied heavily on the Eudoxian theory of proportion, as set forth in the fifth book of Euclid's Elements. This theory had become available only a century before, thanks to accurate translations by Tartaglia and others, but by the end of Galileo's life, it was being superseded by the algebraic methods of Descartes. The concept now named Galileo's paradox was not original with him. His proposed solution, that infinite numbers cannot be compared, is no longer considered useful.